Hey guys, so welcome to Great Learning. Pandas is one of the most used libraries in the Python programming language. It is very popular for data manipulation and analysis in particular, as it offers easy to use data structures such as series and data frames, which are foundational in the world of data science and analytics. This makes the Pandas package to be one of the most important packages for data scientists and analysts working in Python today. Hence, it becomes super important for all of you all to have expertise in this library. Now, this video on Python Pandas consists of an ample amount of theory and practical hands-on sessions that will help you concrete your understanding of the same. Now, with that, I know you guys are super excited to get started. Well, what are we waiting for? My name is Anirudh Rao. Let's go.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so to talk about what is being covered in this particular session, we're going to start out by understanding and having an introduction to Pandas and the data structures that Pandas offers us. Right now, once we have an introduction, once we know how to work with them, we will dive right into the heart of the concept to take a look at understanding the series data structure and of course understanding how we can go on to use data frames as well. Now, once we've had some experience with using both series and data frames, we will have to take a look at the various methods and the operations that we can go on to perform when we are working with data frames, right? So we're going to take a look at all of that and more. We're going to be also taking a look at understanding how we can go on to work on selection and indexing operations, alongside finding out how we can effectively make use of the aggregation operations that are present in Pandas as well. So I hope all of you all are clear with what it is that we're going to be covering today. On that note, without further ado, let's get started.
Now today we will work on two important packages, and we will do a case study also, complete end-to-end case study of how to, when a data set is given, what are you going to do as well. Okay. So with that, so we will discuss one package called Pandas. Pandas was again built on top of NumPy itself. Okay. So what is this Pandas? How different it is? What is the speciality of this particular package for us is, it will help because data is not always in the form of an array. Correct? Data will have, obviously data is in the form of array only, multi-dimensional array only. You know what is a table? A two-dimensional array, right? With lot of different values. But if you want to work on that particular thing, what are all things that we are more got used to, a concept called table. Right? What is a table? It's a two-dimensional, right? Stuff data with different data types stored in it. And most importantly, table for me looks like a column. A column will have a name. Now, have you ever seen a table with a row name? That's exactly data frame is, in simple lines to understand. So what is data frame now? What is the advantage of having a row name? Normally rows will have a row number, correct? This is 1, 2, 3 like that. Let's say similar to index. Indexes, we know always indexes are difficult to understand. So we know this row belongs to a particular student. This row belongs to a particular customer. This row belongs to a particular stock. This row belongs to a particular company, whatever, right? I know column, this column is mark, this column is stock price, this column is sales revenue, whatever. Similarly, can I have a name to the rows also? If I have row name, what is the advantage? So you know what exactly you are doing with it. Otherwise, the operation is same. Right? So that's what exactly is our data frame is all about. So data frame, this is a nomenclature that if you can understand, this is what we'll use consistently so that you will understand it. You already, most of the things you know already. What is this? Column names you know already in this data frame. Okay. And index label. This is an index. Every row has an index. By default, the index is 0, 1, 2, 3 like this. We know that. If we want a specific name to be given to that, we can give a index label a different index also. Okay. So, and index axis is equal to 0 means row, axis is equal to 1 means similar to what we have seen in NumPy. And whatever that is there in between is called data. And if the data is not available, it is considered as NaN. Not available kind of a thing. Okay. So these are called missing values. That's it. If you understood this, we can now do a deep dive. If you have this, let's apply some. See, always learning should be starting from known to unknown. What exactly we know with if a data set was given to you, you are not a data analyst. You are not trained on this particular ML or whatever this algorithm or courses. What normally you do with a data set? If you look at this thing, what do you do? What sort of operations you do? You look at the data first. You'll see all the data. If the data has 10,000, 100,000 records, what do? You try to see first few records, is it? You'll not go to the entire thing. Correct? So you try to see the first few records. Hey, show me what is this data is. First of all, you'll ask what is this column? And you try to understand what is this column type. What is column type? What it will help us? It's a numeric data type. What are the data types you know? Number, string, or a boolean. In our data science terminology, we call as categorical variables, numerical variables. Okay. So what is numeric variable? A number. What is a categorical variable? This is a category. In data science, you will never ever work with unique values. For example, customer name. Do you analyze customer name? You will not do that. Because customer names are always supposed to be unique kind of a thing. Right? Even if it is not unique, we'll have a unique value for that customer ID or something. So we will never analyze a customer name. What we will analyze? We may analyze his date of birth. We may analyze his years of experience. Or we may analyze his number of products he sold. That is what our data is. Correct? For example, if a customer has bought a product. So product is a data point to me. But it's not just a string. It is a category. Correct? It's a repetition is possible. So these are all called categorical variables. So in the again categorical, you have ordinal, non-ordinal. You learn all these things when you are learning statistics and basic things. So there are different types of data that you analyze in a statistical way, right? That particular thing you will do anyhow. That is not numeric, non-numeric first of all. Categorical is non-numeric, right? For example, customer product, what a product he bought. So this is a categorical variable, data. There's a category, which product he bought, correct? And else, what else? His gender, male, female. It's a categorical variable, right? What is the order type or the shipment type, where he is trying to ship the product, right? Shipment type is home delivery, office, whatever, right? Or through what means of delivery it is. Shipped through air or through road. Shipment type. What is it? Again, it's a category. It's not a number. Correct? So when you have this data, then you look at the data types, then you look at the initial values, and then what else you look at? What else you do? That's exactly what we are going to learn today. How to do it through Python. That's it. Otherwise, whatever I am going to show you today, which you already know, we are only trying to learn how to do it through. If the data was given to you in Excel sheet, what do you do with the data? You try to understand each and every variable one by one. So in each and variable, if you are a numeric data type, the way you look at the data is different. If you look at a categorical data, the way you look at it is different. For example, if it is a numeric field called sales revenue, how do you look at the data? What are all things that you try to understand from the data? You try to understand what is the minimum sale. What is my maximum sale? This is called range. What is the minimum? Maximum. Range. What is the average sale? That is another value. Right? So what is average is nothing but mean. Correct? But averages are always dangerous. Why? There is a word called outlier. Everyone understand what is outlier? There's no need to worry. Outlier means the biggest value for now or a smallest value. If for example, let's say all the average of age in this room, right? Most of us are in the same range, let's assume. And if you have an outlier, so what happens? The average increases, right? And if I have a 5-year-old boy sitting in this room, then that means average might not give the actual, trying to get the proper understanding of the data, because it will get pulled towards usually the extreme values. Let's not call it the outlier, right? We call outlier for the different concept. The extreme bigger values or smaller values, extreme values, we call extreme values, right? So these extreme values will be pulled by the mean. So that's why there's another concept called median, which is nothing but 50th percentile. Have you heard a word called percentile? 10th percentile, 20th percentile, right? So percentile. So what is 50th percentile? That means exactly if we put all our ages in an ascending order, I'll take the middle one. That will also tell me what is the average age of this kind of, it is better than the average. So median is also an average concept only, right? And then what is the common age factor that is there? That's called mode. Most of us are 32, let's assume that 32 is the mode, correct? That is a common thing, right? And else what is the variance? How much of spread it is there? What is called variance? Variance means variation of the data. You are 32, I am 39, somebody is 47, somebody is 36. There is a difference between the mean and your values, right? So what we try to, with the help of a mean as a base, we try to see how much of variance in the data. Example, if the variance is very high, that means there is lot of spread in the data. It is not actually closer. If the variance is less, that means more or less everyone is of the same group, right? By how means? That is exactly called standard deviation. Variance is usually not in the same metric, what that particular parameter. For example, age is in numbers, right? The metric variance might be in some other metric, because you do a square of it. So now I'll not get into the formula of it. The simple formula is your value minus mean. Simple for now. Just understand this. So then we'll sum it up, and then divided by number of data points that I am trying to get it, and I'll get a variance. So if then some value, for example, the mean is 30 in this room. Let's say the average mean is 30 in this room. His guy is 32. Let's say I am 27. What happens now? Plus 2, minus 3, minus 1. So something will be plus, something might be minus. To dissipate these pluses and minus, what you do is you square it. You want to find the average, right? So there are some pluses and there are some minuses. Now what is the total variance that you want to calculate? And then you average it. That's called exactly the variances. So in this process, if there are some positives and there are negatives, I don't want that negatives to take away those positives. So what I'll do is, I'll square it. 2 square and 3 square. I'll say the square of it. So 2 square is 4, 3 square is 9. 9 plus 4, 13. 13 divided by 2. Then you'll get the variance. This is in roots. This is in square, because the average is also now the variance is also in square. Then I'll take a square root of it, because I did a square. I'll do a square root of it to bring it back to the normal scale. Then I'll get an exact variance. That is called standard deviation. So we talked about standard deviation, and then we discussed about now categorical variable, right? For example, now categorical variable like what is your education qualification? Degree or a PG or a PhD, whatever, something. So if I want to count how many degrees are, then we will not do median and mode here, right? Median or mean we will not do. What we can do? We can do mode. How many? What is the average? What is the most common qualification in this room? Is it degree or post graduation or a PhD? We can say that, right? That is exactly, it's called mode. Okay, but will there be any mean or median for this? No. So usually what you do, you'll count. How many means are there? How many degrees are there? How many postgraduates are there? How many PhDs are there? We can do even count. Correct? This is all called univariate analysis. That means I'm analyzing only one variable at a time. Now if you combine two variables, that is called bivariate analysis. What is bivariate? It means more than 2 here. Or multivariate analysis. So I can combine degree with my salary and trying to understand what is the salary for each particular kind of a category. So degree have different salaries. Postgraduate have different salaries. Doctorate have different salary figures. From this, looking at this number, I can understand certain things. What is the average of degree salary? What is the average of postgraduate salary? Will it help me to understand the data better now? What are all these things called? Analysis. Just we are trying to analyze, understand the data. And not even analysis. We call it simply as understanding the data or summarizing the data. Correct? What are you doing? We are summarizing the data. Correct? So, this particular thing we do it every day almost. If you go to cricket, right? We all play cricket. We will say, what is Shikhar Dhawan's average overseas? What is Shikhar Dhawan's average in a particular country, against a particular country? What is Shikhar Dhawan's average against right-hand bowling, right-hand fast? What are all these things we are analyzing? We are analyzing two variables now. Correct? The batting and the batting scores, the runs scored with the type of the group. What is the group here? It might be overseas and India. It might be type of the bowler. It might be. So what is the type of the bowler? Is it a categorical variable or a numerical variable? Fast bowler, medium, spin, left arm spin, right arm fast, left arm fast. All these things are categorical variables. So you can analyze data in multiple ways, isn't it? What else you do? You do this grouping also, no? So this is nothing but grouping. Now we are grouping by something and then doing an average. So grouping we do. Filtering we do. We'll take only overseas data. We'll not take, India data. That is what are we doing now? We are taking overseas. And we are going to analyze only with fast bowler. Then we are cutting the column wise. Row wise, column wise, slicing, dicing. Again we'll also do data frames. Filtering, that's what we do. What else you do? If there are missing values, we have to work on those missing values. And the data is in two different data tables. And you got from Excel sheet, other from data tables. Usually in Excel sheets and all, what you do? You do create a cross tab. You create a pivot table for this analysis. That's exactly we do. So now let's learn all those things, how to do with. And in this process, certain things, normal aggregation numbers itself is fine. Sometimes we want to visualize that also. Not just the number way, we want to visualize that also. First thing is python.org. See, another interesting thing for people who are now doing coding or first now starting coding kind of a thing or restarting coding, whatever, right? Most of the times these codes are already written, but for a specific purpose. For example, you want to know how to define a function, how to create a function for doing certain activity, right? So what do you do now? You want to get the syntax. The syntax you will get it directly from the reference document itself. But you don't write the logic. Where do you struggle normally? Logic or the syntax? In writing the logic. So logic, how to get it? That's what there you need to understand what are all tools available to me. Okay. I'll show you one thing. See, normally who does this particular thing, different people will write different blocks. There is an analytical competition platform called Kaggle. Have you heard about a platform called Kaggle? Kaggle. So what Kaggle is? It's a platform where companies come and run their give an opportunity for all the data scientists. It's an open source platform where they'll give a data set, they'll give a problem statement to you. And they'll ask you, come on, this is the metric I'm looking for to improve. For example, Netflix, they already have movie recommendation stuff. Netflix company, right? They have a movie recommendation engine they have already built. Currently, their metric accuracy is around, let's assume 84%. With the data that they have built, with the algorithm they have used, 84% they are able to achieve. Now, they'll keep that particular thing in Kaggle and say, boss, this is my 84%. Can you help me improve it? Whoever does the best improvement will get a prize. Right? So, that's how they put it. Usually commercial things won't come to Kaggle. Non-commercial stuff will come to Kaggle. Example, they want to find a rare species in a forest. They have collected lot of sounds of different animals. And they want to find whether that animal exists in that particular thing or not. And you want to classify all the sounds. Correct? So whoever correctly able to classify that will get a prize. So these people who are winning the competitions, what they do is write a blog. If you look the entire Python stuff now, right? So it is the Python what you are going to do now from the after this class onwards is not about Python program as such. It is all about, that's why today we'll case study will help you understand the process better, and then how to find for that particular things also better. Absolute basics, right? You get the basics correct so that you whenever when somebody writing a program, now you're able to understand and read it correctly, and then you can start writing as well, because now you know what exactly things to be done. Okay, before you get into data frames, you have to understand two important things called series and data frame. Right? So data frame is a multi-dimensional thing, correct? A series is a single dimensional stuff. That's how you understand. Series is also similar, very, very similar to data frame, but data frame is a multi-dimensional, but series is a one-dimensional object. Series also will have an index label and a column name. Correct? That's what you can simply understand. For example, I created a series pd.series 1, 3. That means what internally I have given, a list only I have given. And in that there are null values also. Whenever you have a null value, how do you pass it? np.nan. Okay? So like this you have passed. Now what is this? Now this is the row label, correct? This is the row index. And this is the column for it. What is the data type of it? It's a float. Now if let's create a data frame also. How do you create a data frame? Say I did pd.date range from some date I have given, and periods is equal to 6. Since I didn't give any frequency, by default it takes date as a frequency. So what this particular function will do is it will create a series. It will just simply create a series of ranges of 6 numbers. For example, look at the print the dates. Now you see 1, 2, 3, 4, 5, 6. Frequency is equal to D and everything. It's created some range, some dates. Now I want to create a data frame now. And I'm creating a pd dot similar to pd dot series, or right? We have created np dot array kind of a thing. Now we are creating pd dot data frame. What is the first value? Is the values. What all values that should go into data frame? I'm using numpy only here. np dot random dot rand 6, 4. What it will do? Tell me. That means rand n means it's a normalized data. So it will create some random numbers, floats only. Okay, and then it will create it. For this particular thing will only create this thing, right? Now I am giving some names to it and some row names also to it. That's what the difference between a normal array and data frame we discussed now, right? So otherwise it's a multi-dimensional array only. Index is equal to, that means index, that means the column index. That's the name we discussed now. Index is equal to dates. That means these are the indexes. So ABCD is converted into now A, B, C and D. It's a simple thing only. Okay. So now we understand what is this data frame looks like. What is the column? What is the row index? Okay. How do you understand this example is, don't go by this range and all. You try to understand how a data frame is created. Data frame is created, first one with values. Second one is index label or the row label. Third one is the column label or column index. So now if you look at this data frame, if I want first row from this data frame, so what I can do? df square bracket 0. What it will do now? Sorry, first row will get it. But row has a name now. Instead of row number based, I can say df of The index name also I can give. Df dot, column name also I can give here. Dot, this is a dot operator. Df dot A, Df dot B, Df dot C. I want second and third columns. Now df of, you can give the list of the names. We'll see all that thing, how to do it. Let's learn Jupyter a bit more now. Help and keyboard shortcuts. What is the new thing? Shift enter or control enter. What is the difference between shift enter and control enter? Shift enter will move your cursor to the next command, whereas control enter will stay there itself. Will execute the command and then will stay there itself. Okay. Similarly, if you want to insert a row, example, I am here. I want to insert a cell now. How can I insert a cell? Here you can say insert cell above, cell below. Example, cell below means, so cell above size, it says inserted a cell. Where am I now? Here, right? So if I want to insert one more cell, insert cell below. So it is inserting one more cell. This is how. And there is a keyboard shortcut also for it. What is the keyboard shortcut? If you look at, there are two types of command modes. One is the escape mode, which is a command mode, and the other one is the edit mode. Two types of keyboard shortcuts for you. One is for editing the value and the other one is the command related activity. So in that, there is a command called A and B. A means insert cell above, B means insert cell below. So one way of inserting a cell below, if I am here, right, I want to insert one cell below now. So what I can do is go to menu, insert. The other one is escape and B. Escape A. Are you getting the thing? These things slowly you learn one by one. Without using mouse, you should be able to. Is it a rule that you should not use mouse? To improve your productivity, that's it. Right? Rather than going to say insert, cell and all, which is easy now. Escape A, escape B is better, right? So this command, the shortcuts are only for improving, nothing to do with your capability. Okay? That's good. Okay. Now let's see this. Now importing a package. What is happening here now? I'm creating labels. What is labels here? A list. I can create list also other way. List is equal to something. Instead of list, I can say ABCD is equal to something. All the same, correct? I can create whatever, some AB is equal to something. An array, here what is this array? Can I give array, this name also, array name? Don't get confused with this name. So dictionary. So what is the difference between dictionary, array and list now? Now if you look at, create all these things, right? Now if you try to print labels, what is the difference here? What is the difference? Both are same only, no? Only array has came forward. What is the advantage now of this? Now because of this, array dot, I can say mean. I get a mean. Can I get a mean like this? Why? Because this array was created using numpy array. This is not a simple array. It's an numpy array. What is the advantage of, if array also a list only, list of lists only, what is the advantage we have? Because numpy has built-in functions for us, where we can use to manipulate, slice, dice and all those things we can do. Append, all those things we can do easily, correct? Okay. Now I am creating a series. What's the error I got? Tell me how to fix this error. It is telling boss, data type is equal to list. What I said, data is equal to list. It's telling boss nothing. So here, what is the name I have given? AB, correct? I should give AB. Now I got a. Why I am doing all these things is to make sure that you also do, you will also do this kind of thing. You create with some name and you try to do something with something else. Computer can't understand all these things, right? You assumed it is there, but if it is not there, you'll get an error. So what did I create now? I created a simple series. So for creating series, what did I say? PD dot Series. What is series? One dimensional data frame. Simple in one way. Correct? So, for this series, what is the index actually? 0, 1, 2 like this. But if I want to create a series, the same AB only, but with labels. What are my labels I created? WX something I created, no? What will happen now? Now instead of 0, 1, 2, 3, what I am getting now? Something you understood now? So if I have a dictionary here, see already what is the advantage of a dictionary? You already have a key and name. Can I convert this dictionary into a series? And automatically it is intelligent enough to understand keys are nothing but my indexes. So simply if I create a series based on a dictionary, right? It automatically created. So if you already have a dictionary, it is easy to convert that into a. And have you seen this again? In the dictionary, all the values need to be of the same size. Correct? Here I can have like this? What does this dictionary have now? First value is 10, second is a list, third one is a single value, fourth one can be a list of some characters or strings here. Can I have like this? Now if I create a series from this, what will happen? Same thing. Because series will have only one single column. But this is not my single column. This is a different value. Right? So how should I do now? I should create a data frame now. Okay. Now let's assume I have a series of sports 1. So another interesting thing, just what I am doing is, my previous output is here, right? Whatever I have executed previously, it is here. So what I did is, I have cleaned that entire thing and I have cleared all my output. So that the previous output will not appear now. So what did I do now? I created a series of values 1, 2, 3, 4. What is the index I have given to it? Cricket, football, something I have given to it. So what is this sports 1 will have now? This is nothing but a row name, correct? And I create one more series, sports 2. This is another data. This is I have 2 datas. Right? So the advantage of indexing is, instead of you remembering the number, you directly remember the name itself. For example, in that I want to know cricket ka data. So I can say simply sports 1 of cricket. I can even do addition operations now. Sports 1 plus sports 2. What is the expectation now? This have a different index, this has a different index, right? If index are zeros and 1, it will do 0 plus 0. 1 plus 1. Now I have index. What it will does is, right, if you look at this one, not necessarily everything should be in the same order, no? But it can even do the index based addition. So cricket in this index will be added to the cricket in another index. Shall I do this? Sports 1 plus sports 2. Why did for baseball I get an NAN? Because baseball is there only in second one. First one it didn't have it. So what it did do? It's not able to. It only matches the value. If it didn't find that value, it will not able to. Even it's not 5 plus 0. 5 plus nothing. 5 plus nothing is not 5. 5 plus 0 is 5. But 5 plus nothing is, I cannot do. You understand the difference? So what exactly it is doing now? It is trying to match index to index, right? So minus, plus, all operations, all the operations what we can do. Okay. So this is another way of importing packages. Now, if we have a particular class in a package and you want to import only that particular thing, you don't want to import the entire package. What will happen if you import the entire package? Your size of your program will increase, isn't it? Because you are getting all the things. So if you want to only restrictively bring only certain things, then you can use from operation, from command. From this numpy.random, you import only rand n. That means don't import the entire numpy package. This is another way of importing only whatever you want to import. You understand, everyone? Okay. Now I am creating a data frame. How am I creating data frame? pd.dataframe rand n 10, 5. See, I am not calling np.randn.rand now. Have you seen this now? Directly I am able to use randn directly. I can give a randn as rd also here, so that I can see rd also. Okay. Okay. What randn will do? It's creating a 10 by 5 matrix. It's a normalized matrix, correct? I want to create a data frame like this, right? I want to give a row name to it, and I want to give a column name to it. What I am going to do now? Boss, create my data frame. These are the values. Okay. And in this values, what is my index? That means what are my row names? How many rows I am going to have? 10 rows. So I am giving 10 index names. Okay. Directly I am using split function here. The other way I can create is simply abcdf list also. List.abcdf. Right? Then I am creating, and these are all my scores. Score 1, score 2, score 3, like this. I am creating this particular thing. What will happen now? The same thing will appear as, if we print this data frame, the same values here, right? Whatever the values here seeing, the values here. But you are seeing a different value here and here. Why? I created here. Hey, here itself values are changing. It's a random number, no? But sometimes these random numbers are difficult for explaining to someone else. If you try to, every time is random, you execute something here and you go to your customer and you show something, it will be different else. So how do you lock this random? You want random only generate, but you want to lock that. So for that, we use a concept called CD. If you use the same seed, you'll get the same randomness. Example, I'll show you here. Okay. So I want to generate a random integer between 1 to 100. Okay. If I don't have this seed, I'm getting 62, 17. Every time I execute, I get a different number. But I want to this random number only generate between 1 to 100, but I want to lock it. Then I put a seed. This seed can be any value, not necessarily 5. If I give 100 as my seed, 9. Every time I execute, I'll get only 9. From a data set, randomly you want to generate some training data set and testing data set. So in a data science project, what we do is, this testing is not a regular testing of software application testing. Correct? For example, you are building a model to predict the score of India or how much runs India is going to score. Or you are going to predict a model whether we should sell it to the customer. He is going to be a good customer or a bad customer. Let's assume. Make you clearly understand. He is a good customer or a bad customer. How do you know who is going to be a good customer or a bad customer? That's what the goal is. So that you give only loans to good customers. You will not give loans to bad customer. Okay? So what you do now? You see the patterns of historical data. Who was your good customer and who was your bad customer? So based on certain parameters. So what are the features on parameters on which I am going to build the model now? Past historical customer data. How much loan he has taken. When somebody is taking loan of this much, he might be turning to be a bad customer. That means the loan amount. Type of loan he is taking. Home loan, vehicle loan, right? Personal loan, whatever. Type of loan. Some details about that customer. What type of customer he is? Does he having savings account with us? Yes. What is the average balance that he maintains in that savings account? Right? What is his age? How many dependents are there for him? What sort of company he works for? Right? What is his education qualification? Blah, blah, blah. Can I create some features now? So based on these features, what I am going to do now? I am going to build a model. I am trying to find some pattern. Again, whenever you say model, you must simply understand what I am trying to find a pattern. The pattern is like this. Let's assume whoever is educated and taking loan more than 100,000, right? And no dependencies. And the savings account balance average is only less than 5,000 rupees. They are all bad customers. That's what model telling. This is not my intuition or this is not my gut feeling. This is what data telling. Right? So what will happen now? What I will do now? If tomorrow a new customer comes in, I will see whether he satisfies this rule or not. If he is satisfying this rule, I will not give loan to him. If he is not satisfying the rule, I am going to give it to him. So what is my advantage? My number of defaulters will come down. My bank profit will increase. Who will write this requirement to you? See, this is what a big picture of the analytics industry. Bank job is to increase the profit. Any business job is to increase the profit or reduce the losses. They will keep the bank strategy team. The board will decide, boss, last year I had my profit is 18%. This time goal to the executive team is increase this 18% to 24%. Profit increase to 18 to 24%. Or last year my revenue or my profit is $4 billion. Now make it $4.5 billion. That's how the goals will be set. How do they set the goal also? Year-on-year growth. Based on year-on-year growth, it's a simple arithmetic progression that they do. Correct? Or a quadratic progression also they'll say. That's how usually see all these people who have set the goals, right? They're not statisticians. That's why statistics will help everywhere. Okay? And there is no random number in the world. Please remember. If you are, that is one skill that you have to come out of that. There is no random number in the world. What is random number? If I ask you, how many red color Maruti cars are there in Pune? Tell me. Now you should systematically get to that answer. There should be a process for you to reach that particular answer. Whether 1,000, might be 1 lakh. Both are correct, might be. Or one of you correct. Right? How do you systematically come? Just think of now. How do you go? How do you find? What is the population of Pune? Around 40 lakhs people? 50 lakhs? Now I am assuming there are 50 lakhs people. If I want, I can get the Google something, right? Some 40 lakhs or 50 lakhs people. That's the density of the population of Pune. Okay, out of 50 lakhs people. Now I'll have one more assumption. I'm not guessing. This is an assumption. Assumption is different. Random number is different. I'm assuming there are 50 lakhs people. I'll make one more assumption. Out of these 50 lakh people, what is the average family size? 4 people. Right? So that means 50 lakhs divided by 4. How much now? 12.5 lakhs. That means 12.5 lakh families are there in Pune. In this 12.5 lakh families, right? So if you want to own a car, your average income should be more than something, right? At least you should have a 10 lakh income. Again, an assumption. Okay. I am assuming at least 10 lakh should be there, minimal, to own a car. Okay. So that means what is 10% of, how many people will have a 10 lakh salary in this thing? Let's assume the average income of Pune. So based on that, I am assuming 10% will have more than 10 lakh salary. Right? So what is 10% of 12.5 lakhs now? 1.2 lakhs. 25 lakhs, whatever. 1.25 lakhs. That means 1.25 lakhs have a salary of average. So I am assuming all these people will be owning a car. More than 10 lakhs, living in Pune city, big city, have to want to go. But they want to own a car, let's say. Again, an assumption. All these people are owning a car. Not necessarily everyone will be owning a car. I can make another assumption. Only 80% of the people will be owning a car. Then my 12.5 becomes, let's assume 10 lakhs. Sorry, 1 lakh. So 1 lakh. Now this 1 lakh among the cars, what is the Maruti share? Around 40% of the share is Maruti only. Let's say 50%. That means if these 1 lakh people are owning a car, how many of them will be owning a Maruti car? 50,000 people might be owning a Maruti car. Okay. And what is the prominence of red color Marutis usually? What color normally you find outside? White color or a grey. So if I am assuming a percentage of 5% or 10%, whatever. I can assume again another percent. Right? So everywhere I am making some assumption and I am documenting that assumption. What is the red color percentage? If there are 100 cars, 100 Maruti cars, I am assuming 10% will be or 20% will be red color. Let's assume 20%. Then out of the 50,000 cars which are owned by Maruti, what is the percentage now? 10,000. Now I came to conclusion how many red color Maruti cars are there in Pune city? There might be 10,000. What can go wrong? My assumption can go wrong. First, Maruti share might be in overall India is 50%, but in Pune people like Hyundai. And Maruti share is only 20% here. Then what the number I will change in my calculation? That 20%. Hey, Pune population is not 40% here, 40 lakhs here, it is 70 lakhs. I will change that. Right? Average income of Pune more than 10% lakhs is not 10% here, it is 20%. Pune is always a rich city. I will go and change it. My number automatically will. Now have you seen how systematically I am able to solve a problem? This is called analytical thinking. This is not random thinking. This is clearly an analytical thinking. This is one skill which people will look for when you are being interviewed in an analyst role, as a data scientist role. Because not data is readily available to you all the time. You have to make some assumptions and then fill that data. If you are filling the data randomly, what will happen? Your model also will be random only. So if you want your model to be more relevant or accurate or close to reality, because you have to fill your data also. Why I told you all this entire story is how to analytically start thinking when you are creating your data also. You may have to create your own data set. And there's a good thing on this particular thing. You can start thinking like this. Anything that people ask randomly, even you don't know the answer, direct straight answer, but you can systematically come to an answer. What is the weight of an Boeing 333 aircraft? You said randomly some 7,000 kgs or 100,000 kgs. Just systematically can you think now? What is a Boeing airplane is? What it is made of? How many people usually it will carry? What sort of weight of the luggage? How much of fuel it will carry? What will the volume of a 1 liter? Convert it into kgs. And how many seats will be there? What is how much of food that will carry? Blah blah blah. Right? All these things. If you do a systematic assumption, what again you can easily calculate the weight of the Boeing Any random number for that, any random question for that matter. This is one skill people will continuously will check. What is your analytical thinking capability? Now this is one skill that you can easily pick up, right? Particularly when you're working in research, these things are very, very important, because research you will not have enough data. You have to generate some data. Now understand this, we're discussing about that training testing thing, right? So you have built your model on historical data only. How do you know that your model will work? From historical data, you have tested it. You have found some pattern. Is your real pattern is working or not? How do you check that? Because you go and start applying that model now. After 3 months, once you know who are the defaulter, who are good customers, then I will tell you. Then already you lost the data now. So what you will do now is, from that last historical data, you will hide some data. You will hide some data. You will not use that model data to build the model. Right? You keep that data aside and you build a model on some data set. And after you found the pattern, you apply the pattern and start predicting on this hidden data set now. This hidden data set actual value also. Now you will compare your actual value versus your predicted value. So now you know how much accuracy, how many correctly you are able to predict. Correct? So this particular thing is called training and testing data sets. This data set is called testing data set. So what happens is, every data scientist, whenever working on any model, whatever data that was given, we'll break that into 70-30 or 80-20 ratio. And we'll randomly generate the data. If you're randomly generating the data, you run today one time, you get randomly some other record. Tomorrow you run, you get another randomness. You want only one, but this particular testing data should be fixed. Randomly only generated, but then that randomness should be fixed now. That's where you use seed. Understand where exactly you use seed and all. So whenever you want to do something random only, but that particular randomness you want to generate only once, and that randomness has to be locked. Then you can use a seed. Seed need not be 1 or 100 or something. Whatever number you want, you can give. 10,000 also, 5,797 also. What is seed? That's because randomness is also not a random number actually. Computer generated random number is not a random number. It's an algorithm. Random generation itself is an algorithm. For that algorithm, it needs a seed. For example, you are listening to the songs, correct? Shuffle mode, if you are listening. Have you noticed the same songs will come in the same shuffle way? If you shuffle and listen, and if you're repeating it, and shuffle is in repeat mode, it will shuffle in the same order. There's a random number for that also. There's a seed for that also, as well. For now, seed doesn't help you now, but in future it will help you. I created data frame now. Now if I want this data frame to be fixed, what should I do now? This randomly if it is generating, right? Creating a data frame based on random number only here. So now I create a data frame. Now if I ask it, it will give me a different data frame. I want this data frame to be fixed. What should I do now? Just put a now this is something. Now I got a new data frame. Now I execute again. Remember 1.74 something. It is 1.74 only. It's not changed. You understood the logic now? Yeah. Now, basic things that we will do with Pandas. What all things that we do? I want the score 3 column only. I can say data frame of score 3. Okay. I want score 2 and score 1. See, I have changed the order also in which I want to get it. Can I get it now? So how am I using it? Again, a list I am passing, correct? List of names. What is the return type of a thing? It's a series. Remember, see this? It's a single value, it is a series. If it say type of this one, what it will be type of this one? It's a data frame only. If you are returning a single, that means from a data frame, if you try to extract something, you are getting a data frame or series. If it is a single value, it will be series. If it's more than one value, it will be data frame. Okay. And now, if you want to add a new column now, I already created data frame, I want to add a new column, right? So, which is a combination of score 1 plus score 2. Can I do this? So, how am I doing? I am creating a data frame, score of 6, this is this one. Now, what this data frame will have? Will have a new column called score 6, which is a combination of score 1 plus score 2. And I can drop a column also. How to drop a column? Drop. Now, what has happened now? There is no sixth column now. I have added a column, I can even drop a column. But if you look at carefully, we go and ask again a data frame. If you just list the data frame, you are getting 6 all things again. That means it dropped and created a new data set for you. It didn't modify the existing data frame. It has created a new data frame here. For example, if I say x is equal to, x will have that 5 column, that 5 column stuff. Escape below. If you say x, you'll see only 5 columns. But if you go to data frame, obviously it will have all the 6 columns. You want to modify the existing data frame itself. You don't want to create one more data, because every data frame you're creating, you are increasing your memory utilization. Right? You want to directly modify within the data frame itself. Then there's a parameter called in place is equal to true. By default it is false. You can use in place is equal to true. What it will do now? It will delete the data frame within itself. It will not create a new data frame. You understand? And if you want to delete a row, now you have deleted a column or you have added a column. Similarly, if you want to drop a column, drop a row, then you can do that. But instead of dropping, you should mention axis is equal to 0. Axis is equal to 1 means columns, axis is equal to 0 means rows. Again, what will happen now? A is deleted, but not, it has created a new data frame now. You can use in place is equal to true, so that it will create. If you go to data frame, still A is there. If we want to replace really 0, what I should do? What I should do? In place is equal to true. Now it will delete actually the data frame. No, it is not there. So for selecting rows, one of the option is you can use the square bracket and say the names of the column. For example, I want the B row to be coming out. How should I say? Can I say B like this? If I want score 1, how can I get the first column? I can get like this, but I cannot get the rows like this, right? Even I can get scores in another way also using dot operator called score 1. You can get like this, score 2 or score 5. I can get. But how do you get the rows? Rows, for that you can use location. A method called location. Location, LOC of F. Then you get the entire row as a series. This is as a series because the entire row became a series of values. Okay. F. I can say P, B, whatever. I can get a series of things. Okay. Or if you want index based only, you don't need the number. Number is not there. Sorry, name is not there. Index value is not there. You can get it location based on index also by second row. I want fifth row by using a method function called iLocation. ILLOC. Okay. If I want more than one column and one row, I want a row, but I want score 1. Do we have A in the data set now? I have dropped it. So we cannot use A. What will happen? Let's see if I use A. It will say, boss, I don't have A here. So let me get B here. Can I get now? What is this now? A single value here. Because exactly I am trying to know, I know this row and this column. I let only get that particular thing. Okay. If I want more than one value, I want A and B rows. For that I want to get both score 1 and score 2. Or C and D. Now this is a data frame again. Are you getting it? So now do you know how to do slicing and dicing now? If you want particular column to be filtered, you only see a particular column. Select. Just like this is like database operation only, no? Select something, right? And you want some rows, you can say rows here. Okay. So location and iloc can be used for location based stuff, and dot and directly column name can directly for columns. Then the conditional selection. What is conditional selection? You are directly telling this column, this row. I don't want that. I want based on a condition. Just like where condition we will write now, where salary greater than 100, like that. If I want it, I have in my data frame, I want to know all the values in the entire data frame, which has greater than 0.5. What it will do me? It will give me true false Boolean matrix. Boolean value data frame. It means wherever true is there, those true have value greater than this thing. So if I say, what does it mean? I'm getting the row 5, and in that row 5 I am checking whether something is greater than 5 also. But if I say this, if I say within the value, so what is the difference between this and this? This is on the entire data frame. I am saying go and compare every value of it and tell me whether it is true or false. But here I am telling, in this data frame, get me the values like this. Have you seen the difference now? It is trying to compare and get me that exact value. And if it is not able to compare, if it is not true, then I will get an NaN. But what I want is not that. I want to see all the records of the scores. Score 1 may, who is greater than 0.5. Then I will get it. I will get only those records where score is greater than 5. Okay. I want to compare score greater than 5, but I don't want all the columns. I want only to get second column only. Then I can say this. And what is this now? This is the same values, correct? If I say here 5, I'll get exactly these values. That means I am applying row and where condition and also select condition. Are you all comfortable with select queries? Select column name from table where condition. Do you need to have include your where column in the select column? Not necessarily, correct? If you want all, you can get all. But if you want only restricted to certain things, you can apply that particular filter also. Now look at this data frame. The data frame has, this is the index, correct? B, C, like this. B, C are not good, let's assume. I want to rename that to a proper country name. So I can reset the index. If I reset the index, what will happen? The index will be 0, 1, 2, 3. And have you also noticed index become a column now? Earlier index was only a row number, a row name. Now index became a column. Okay. Now I am creating a new index. Now these are all my 10 countries. I am creating a simple list now. Now what is this new index will have? This is a simple list, isn't it? Now I want to give this list to my data frame and ask it to use as an index. Okay. So, but does it already have a countries field? Does it have a countries field? No. So what should I do now? First I should create a new countries field and I'm adding this index to it. But does it have countries already? No. So what should I do now? Tell me. Do you remember earlier we have added a column, score 6, adding a new column. How did we create a new column? List. That means I'm not supposed to give a list. Example, if I give here score 6 of some values here. How many? 3, 5, 7, 6, 4, 9, 23, 27, 36. How many values are there? 10 should be given, right? 10 should be given to it. How many are given? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should be a series. I can give a series to it. I cannot give a list to it. So how do I convert now this into a series now? PD dot can I add now? You understood now? Because data frame always works with indexes and column. That means it will not work on regular indexes. The index of list is not sufficient for it. Why it has given NaN now? Not a number now? Because there are only 9 here. If you remember here, but I have given now 10. We have removed one thing, no? Still it is the same? No, not. The data type can be, it's other frame can have other data type. That's not the case. Because the index of this particular thing is different from index of this. It's not able to match. I told you in the earlier sports 1 and sports 2 we have tried to see, and for some sports we got a NaN value. Why? Because when you are adding something it will only go by. What is the series? What is this index of this one? 0, 1, 2, 3 like this. Is it any 0 matching here? No. Then no. Will it be able to add? No. So what should I do now? One is reset that so that I can pass it to it. The other one is I can give an index to this one also, no? To this series also, right? How do I give a series to it now? Dot index is equal to, right? What is the index I want? B, C, right? B, C, D, E, F, G, H, I and J. Dot split. Sorry, no need of this bracket closed. Now I should close the bracket here. Now what will happen now? I got it. So when you do a mistake also, you should know what is happening there. Otherwise, you will not be able to correct your own. This is what understanding the concept is. Now understood now? I did it just like you. For a new programmer, what I will do? I am trying to add something. List I am not able to add. Then I realized I can add only a series. But when I am adding series also, when you are adding a new series to an existing data frame, the indexes should match. Otherwise, it will not know how to add those values. Right? The other way is reset the index and then create a new index. That's what we are trying to understand now. Clear? Now I have this data frame which has 6 records now. Okay. Now I am doing a reset index. Now all the indexes become 0, 1, 2, 3, 4. Now I want to give a name to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many I have? Only 9 I have. So I created a new index now. Okay. Now will it work now? Now what has happened? Now this is added as a new thing. Even with the list also you can add, as long as the list also will list. What is the index of list? 0, 1, 2, 3, 4 only. Now you can add it. Okay. Now I have it. Now I want to reset one of the country as my index instead of B. Didn't I reset it? Yeah, this is the old value. Okay. I understand. This is the old value. Now that country became the index. Instead of B, C, D, now country became index. Clear? Yes. Again, simple. This is again changing, not changing the actual data. It is creating a new data frame. So what should I do? In place is equal to true. Then actual data frame will change. So what are all things that we learned till now? In Pandas, this is very similar to what we have learned with NumPy. Selection, additions, and then basic operations. So other thing that you normally do with Pandas is missing value treatment. So in this data, how many missing values are there? These are all missing values only, no? You look at this data frame. These are all missing values. Since you know this data frame, you know by this. But if somebody has you read the data from a text, from a file, you will not know what are the missing values are there. So simply you can say drop NA. That means what will happen now? It will drop all the records that has even one single value is there in the entire row. It will drop that entire row. Okay. So if you want drop columns which has missing values, you don't want to drop the entire row, then what you can do? Access is equal to 1. Okay. Now because only this particular thing doesn't have anything, these two columns have. So these two columns have been dropped. Again, in place is equal to true. It's not true. That's why its original data set remains as is. So the original data set remained as is. I'm only creating a new data frames here. Okay. So drop NA, by default access is equal to 0. That means it will drop all the rows. Now access is equal to 1 means it will drop the columns. There is a thing called threshold. That means don't drop even if there is only one single value, don't drop it. Minimum should be 2. The threshold value is 2. If there is more than 2, then only you drop. That also I can say. Okay. Then it is dropping only, which one it is dropping now here? It didn't drop it because this record didn't have, for example, if you look at this data, this record has 2 NANs. That means it dropped only this record, other records remain, this one and this one remain in the data set. Understood threshold now? Usually you will not drop. What you will do, you will fill the value. Correct? If you drop, you are losing data, correct? What you do, you will fill the values. You will ask business, hey, this value is missing. What should I do now? Business say, okay, sorry, I have given incorrect to you. Just you fill this with some X value. So if you want to fill with some value, I can say fill.na is equal to 0. Then what it did, wherever missing values are there, it has updated with 0. So the other way is, normally you don't put a constant. There should be some logic. For example, age is missing in the group. We are all one data set. For example, one person's age is missing. Okay? But I have experience in another column. What I will do? Rather than keeping 0 or an average age of all the people in this room, what I will do is, what is the average experience of, this guy is having 10 years experience. What is the average age of 10 years experienced people in the room? Then I will use that as that is much more intelligent than randomly putting a constant or a average of the entire data set, correct? So here also that's what I am doing. What I am doing is, some value is missing for baseball, some score is missing for baseball. Should I put 0 for everything? No, what I am doing is, what is the average score of baseball, and I am putting that value in that particular thing. That is a much more intelligent way of, this is called missing value treatment. How do you treat a missing value? There are different techniques in it. This is one of the technique. One of the technique is, find a relevant group close to that particular missing value and put a mean or median or a mode of it. And who will take this call? With the help of some business knowledge. How do I know experience the right field here? I would taken some other field, no? Experience will give you close to the average age. This is again domain knowledge. In this case, general knowledge. But in business, you will not be able to do this. Correct? You need some domain knowledge. So this is all part of our, what is our, in the data life cycle project, which stage we are in? We are in preparing, organizing the data. We are understanding the data. Still we got into understanding data. But we realized there are some missing values. So immediately the moment you realize missing values, what did you do? Either you delete those missing value records or you treat them. Treat them means fill them. Correct? Are we here clear till now? Now let's get into small activities. Or the other activity is, what activity you do on a data set? Groups. Now we'll try to understand the data by using group by. Let's assume I have a data like this, data frame like this. So this is what is this? This is a dictionary, right? Now can I convert dictionary into a data frame? If I convert dictionary into a data frame, what happens? All my keys becomes my indexes, right? That's the case here. Here, what has happened here? Tell me. These keys became my columns here, correct? If it is a series, keys becomes your row indexes. But if it is a data frame, your keys will become your columns. Earlier we remember when the first example we did, converted a dictionary into a series. Then all values become values, all the keys become row indexes. But when you have multiple records, then all your keys will become your column names. Logically correct, right? This is how it should work. Okay. Now there is a function called group by. So how many customers are there for you here? Same customers are repeating. Now you want to group by, a new object got created for you. So you have to store that group result into an object. Now on that group, what you do? There's an object which has only group by each customer. Now on that group, what you do now? That's why always you do an average operation or some numerical operations on it, correct? Now what you do is, on this particular thing if you try to display it, it's an object. See, it's a group. And it's internally created as an object for us. On this group, what you do? You choose some operation. Have you seen select start from grouping also? If you'll not get anything. After that, you say group customer ID, comma, sum of or average of or whatever, something. Correct? That's exactly this happens in even SQL also. Okay? So what do you do on a group operation? You say mean. Instead of writing multiple lines of code, what I can do is group by dot median, I can say. Now I'll get here itself. Okay. So on this group, I can do standard deviation. I can do minimum, maximum, count. I can describe this group. If I want, I can describe the group. There's a beautiful function called describe. Now, if you look at this describe, what it is doing now? So 1001 is one customer you have, one group you have. 02 is another group. 03 is another group. And it is giving me some important statistics for me. What is that? What is the count? How many customers are there in this group? What is the mean of this group? What is the standard deviation of this group? What is the minimum value of this group? What is the 25th percentile of this group? What is the 50th percentile of this group? 75th percentile of this? What is the maximum of this group? Like this, I can get all these values. So what will happen if I transpose this is, I'll get like this. What is the difference between this and this? It's only a transpose of it. But my readability has increased now. So if you are good in reading like this, you can use this transpose. If you are good in reading like this, you can remain as is. Instead of entire transpose, I can also say simply T also. Same thing. Okay. If I want to apply a filter on it, this is also a simple data frame kind of a thing. I can only get only for one particular record now. I want only one particular column. Then I can get only that particular column as a list. Okay. Are we clear on grouping now? So simple only, no? Group by dot whatever operation that you want to do. So another function that we learned in this particular thing is describe function. So describe function only works on numeric. But if you want to work on even with this thing, I'll show you now. For example, actually if you look at this group has customer name and also profit links. It can be something else also. Correct? So, okay, I'm creating a data frame here. I have one more data frame. I have 3 data frames now. Data frame 1 is some customer data. Data frame 2 has some other customer data. Data frame 3 has some other customer data. Okay. Now let's see one more. Escape B. Now let's analyze this data. DAFA1.info is one function I can run. It will tell me what is the data type of each of these information about this data frame. Hey, in this data frame, I have 4 entries. That means there are 4 records. And index is starting from 0 to 3. And these are my data columns. Total 4 columns. First column, this has 4 values. This has 4 values like this, and it is a non-null object. That means everything is filled. There is no null objects. And what is the data type of it? It's an object. Like this, it is telling me. Okay. Now, let's say DAFA1 dot describe. See what it has? It is describing the entire data set, but it is taking only the sales data only, because it knows they are all objects. I will not be able to describe them. So I am not describing it. I am only describing numeric data type. There is a function called include. There is a parameter called include. Include is equal to all. Now I get all the things. Now it has including the categorical and numeric. It has both categorical and numeric. Now customer ID is also getting. In the categorical, obviously there will not be mean, median, mode and all, top and all. So whatever that is applicable, it will bring. Now have you noticed this has brought some other new things like count, unique, how many unique are there, right? Frequency. Because for a categorical variable, what all things you do? How many unique products are there? How many unique customers are there? What is the frequency of the repetition? What is the total count? Whatever that is applicable, that value will come here. Got it now? This is how you can do this. Okay. Now let's assume I have 3 data frames. One data frame like this. Okay. Data frame 2 and data frame 3. I have 3 data frames. 3 different sources I got data from. 3 different sources. Now what operations I do? I'll join, merge, kind of operations only I'll do now. Okay. First concatenation. Concatenation, what happens? Concatenation is nothing but just add. Right? By default, what it does is, it will add horizontally. It will add horizontally. Right? And complete a new data frame got created. Wherever that particular thing is, it has not done on based on. Example, see the data frame like this. It is like this, right? So what it does, it's created, and the different columns are there in every data frame. So all combined together, wherever it is able to match the specific columns based on columns, it is able to match them. But if it is not finding that column, for example, payback is not there in the first data frame, it has filled nulls there. Are you getting the point? So this is so simple concatenation. But if you want concatenation to happen on columns, that means the things should come next to next, not horizontally, but you want vertically concatenation, then you can say access is equal to 1. Now instead of bringing them row by row, now it has done column by column. So in this column by column, now this is a separate record, and this is a separate record, and this is a separate record. Normally you don't do concatenation. What you do? You do a merging based on a column name, correct? This column, wherever they matches, you try to go and get the things. This exactly is the concept called merging is. Now I have 2 data tables. Okay. This is quarter 1 and quarter 2 data, and this is quarter 3 and quarter 4 data. What should I do now? If I concatenate, what will happen? It will come very horizontally, correct? That means Q3, here there is no null value for Q3 and Q4. It will not come, and it will come here. So I want to merge them now. I don't want to concatenate them. I want to merge them. So you can do outer merging and inner merging also. Okay. So you do merging based on which column? Customer ID. So what has happened in the second record, there is no row for customer ID 2, but still it is able to manage and get it, and whenever it is not able to get it, it has placed NINs. But if you said inner join, what would have happened? Only those customers who has a matching only will be matched. You all understand what is inner join and outer join? What are we trying here? Based on a common column name, the value in that column, I am trying to find the corresponding this thing. This is called merging. Now they say the concept of joining comes into picture now for us. So how does joining works is, joining is also similar to merge only, very, very similar. What is the only difference is, merge uses the common columns to combine 2 records, whereas join uses the 2 row indexes to join the data frames. Based on column name it will join. The join will do on the row index. Remember, rows also can have names now. We can do based on rows also. For example, if you look at the data like this, you have table 1 like this, right? I0, I1, I2. And table 2 is like this. Now you want to join them. So table 1 dot join. This is a pure inner join, right? Now if you want outer join, you can do this also. So that you will get all the other records which are not. So by default, it is doing the left outer join here, left join here. Whenever that is matching, it is getting it. This is a simple left join here. This is a left join. But if you want right join, instead of table 2, table 1, you place table 2 and join, you will get a right outer join.
Alright guys, so with this we've come to the end of this particular video. We checked out everything right from the introduction to understand what is Pandas, how we can go on to use it, what are the various data structures that it provides for us, how can we go on to use the series data structure, how we can go on to use the DataFrame data structure, and we took a look at a lot of operations, a lot of functions, and eventually we also worked on how we could handle the aggregation aspect of things as well, right? So guys, I hope everything that is being covered in this particular video is clear to all of you all. If you have any comments, any doubts, head to the comment section. We'll be more than happy to help you out. On that note, thank you so much for watching. My name is Anirudh Rao, and we'll see you in the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.